Today I will be going over problem 20 of the video set, which is at time 0, what is the magnitude of the voltage induced on this figure right here? And so to find that out, we'll be using Faraday's law, which is this equation, which states that this equation here states that the induced voltage is equal to negative n times the change in flux over time. And in this problem, what is causing the change in flux is the magnetic field. Flux is equal to magnetic field times area times cosine theta. And what is changing is the magnetic field, because as time goes on, or the current is changing, which then changes the magnetic field. And so since magnetic field is what's changing, magnetic field is equal to mu naught times n times I, where I is the current, and n is the turns per meter, and mu naught is a constant. And so those are the variables that we plug in then to get flux. So flux is equal to B A cosine theta. And so here's the area, and then this is what B is equal to. And then from that, we need to plug flux into the Faraday's law equation. And so to solve for the voltage, we need d flux, or the change in flux. And to do that, we take the derivative of our flux and get d flux. And all this is the constants from the flux equation. And then this here is the derivative of e to the negative t divided by 4. And so now that we know our the derivative of flux over time, what we can do is plug that in to the Faraday's law equation, and then get this set up for the equation, and then we just have to plug in the correct numbers and solve. And so n, the big N, is equal to number of turns in the wire, and the little n is equal to the turns per meter. And so we can look at this equation over here, and this is mu naught, which is 4 pi times 10 to the negative 7. The 200 is the number of turns in the wire loop. The 10 to the 5th is the little n, which is which is turns per meter. And then the 4 times 10 to the negative 4th is the area of the wire, which we can get from over here. Because it was 2 centimeters, we convert to meters, and then we get 4 times 10 to the negative 4 meters area. And then the current, the derivative of the flux is there. And so we can solve for that, and time at the question we are answering is 0, so we plug in 0 for t, and then we end up getting that the voltage at time 0 on the square coil, so on the square coil, the voltage at time 0 is 0.01256 volts.